Hey everyone, really excited for this chat today as we look at a brand new kind of innovative approach to IoT and network congestion and dealing with exploding data volumes with AtomBeam. Julian, how are you?
Hi, Evan. I'm very well, thank you, and great for having me today.
Well, thanks for being here. Really excited for this chat. And um, before we start, maybe an introduction to AtomBeam. How do you describe the company and your role?
So AtomBeam, it's kind of a company that's been around for a few years. It started with the sort of crazy idea that hey, we could make data smaller. So who hasn't heard about compression? But the idea was we can make data smaller in a much more different way than traditional compression. And so that idea, that brainchild, translated into it actually was backed up by a professor in mathematics from South Carolina, who is our chief scientific officer, and came up with all the maths and everything. And the key thing about this idea is we can do it with very, very, very little CPU requirements and very, very, very little memory. And it's what happened is I used to manage all the product portfolio for Inmarsat. And at the time, and this idea came across my desk, and I went, "That's a fantastic idea. It could work really well for my satellite IoT products." And so that's how I got to know AtomBeam. And then Viasat acquired Inmarsat, and we parted ways. And then Charles said to me, "Hey, don't you want to join this startup company?" And I had never joined a startup before. I always worked for big companies like Amazon for 5 years, Amadeus in the travel IT for 14 years. And so this came along, and I went, yeah, why not? Because the tech was really cool. And Charles saw what I could do in terms of my ideas around products and things. So that's why I joined AtomBeam as the chief product officer to help shape the product and how we can take it to market.
Brilliant. And why is data efficiency suddenly such a big issue now? We have bigger pipes, faster pipes, 5G, all kinds of new air interfaces.
Yeah.
Why now?
Yeah, I mean, absolutely, you're correct, Evan. So why? Because we have 5G and the data is always, so we get much bigger pipe. Reality is, data is like a gas. If you give it more space, it will occupy the space. So if you give people bigger pipes, they will find ways to stuff the pipe with more data, and that's what clearly is happening. But more concrete examples, like cybersecurity, for example. So you need to collect a lot of information about what's going on with your devices, who's connecting to what device, what connections have been made from where to where, etc. All this sort of telemetry information from the devices, and that happen everywhere. More and more now people realize they need to absorb that information in near real time to know what's going on so that they can take action. That then creates more data being transmitted over the network. And by the way, this is data secondary to all the actions that happens from the primary applications. So you now have the primary applications of data plus the secondary, which is how people are making those connections. And is a bad actor on my network? Is the network behaving in a different way? That's one example. The other thing is people forget that with 5G or even satellite or even Starlink, that yes, data pipes are bigger, but they tend to get bigger in what we call the downlink, in the download. So yes, when you watch Netflix, it's fantastic. You can watch high definition. But what happens in the IoT space, for example, they don't need to download lots of data. In fact, it's the reverse. In the IoT space, you have all these remote sites generating a lot of data. They need to upload the data back to the mothership. And that's where the crunch comes, because this 5G or satellite Starlink, the uplink is always like a fifth or 10th of the downlink. And if you do a speed test on your phone over 5G, you will see your upload is much smaller than your download. And that's for good reasons, because as a consumer, you want to download data. But as a business and operating IoT, it's the opposite. So this is where we come in, because all this IoT information, all this log information, measurements coming from sensors, they tend to actually be quite repetitive. And so our system can very quickly learn what are the patterns in the data and replace them with something a lot smaller that you can't read, but a lot smaller. And then at the other end, we can then deal with that information. So what happens is a lot of the data we transmit, we make it human readable. Okay. And the reason is because, well, we need humans to read the data. But what you'll find is probably 99.99% or more of the data never gets seen by a human. So it's actually ways to make it human readable. What you want the data to be is you want the data to be, yes, computer manageable, to be super efficient, but that also will be a very difficult task for engineers and developers to do. And this is where AtomBeam and NotPack comes in. We can make that task very easy. We'll say, don't worry, you can send your log information the way you want it, no problem. And then we will take care of making that transmission a lot smaller for you.
Brilliant approach. So it sounds really interesting, kind of radically different than traditional compression. But what was the first kind of real world use case when you realized personally, wow, this is a big deal?
So one of the first real world use case that, yes, we did a few POCs and, with some sample things, and that's great. It's pretty much done in the lab. What we did is we worked with a fracking company out of Texas, data over Starlink. And we deployed it, and very quickly, we were reducing the data by 80%, so down to a fifth of its original size, which meant initially they were filtering the data, because what happened also with your uplink bandwidth as an IoT business is that you need that constant bandwidth available. And the problem with Starlink is during the day, lots of people are using the satellite, so you have less bandwidth available because you're sharing it with other people. And so then during the night you have more bandwidth. But as an operations, you can't say, yeah, during the day I send less data and during the night I send more data. That doesn't quite work. And so using our software, they were able to send all the data they wanted rather than filtering it down. And in fact, they were considering they could send even more data. And what was quite surprising, and I think everyone forgot that the system was still deployed on the trial van, and it kept going for about 9 months. And it performed in 9 months, sending gigabytes of data every day over Starlink, and with no interruption, no issues. And
wow.
In fact, and it went beyond that, because initially when we first deployed the solution with them, they're starting to say, oh, we're seeing spikes on the data that drops and then it goes back up. What's going on? We were able to analyze what we were seeing and tell them, well, actually, it's coming from one of your sensors. It's not coming from our solution. So there quite a lot of interesting stuff that we could observe thanks to our solution.
AI is changing the game of business. Will you be on the winning team? I'm Jordan Wilson, the host of the Everyday AI podcast, and your coach to help you learn the X's and O's of AI. Artificial intelligence isn't just a new player in the game, it's a new sport altogether. So if you don't quickly put AI into play, your competitors will run up the score. I've spent my whole life building winning teams, from coaching basketball to working with big players like Nike and Jordan Brand. My next move? Helping you win with Everyday AI. Listen wherever you get your podcasts or on everydayaipodcast.com. Let's tap into AI together and put points on the board.
That's fantastic. And I assume many of the telcos and cloud hyperscalers, et cetera, are starting to pay much closer attention to this challenge. What are you seeing, in partnership with them and through them?
Yeah, so I mean, absolutely. So we're in partnership with Ericsson, and one of the key things is, in fact, we said, okay, what we need to do is let's test our product. Does it work over a wireless router, a 5G router, and over an SD-WAN? So SD-WAN typically it allows you to combine multiple network connections and make them look like you're only going over one connection. And so that's called network bonding, but also it offers capability like quality of service, which essentially means prioritizing certain traffic over other ones. And the reason why you want to do that, why do you want to combine two cellular connections? Why do you want to prioritize traffic on your network? Because in both cases, it's because you don't have enough bandwidth.
Mhm.
And our product is there to actually help you when you don't have enough bandwidth. But we solve it in a different way from SD-WAN. SD-WAN solves it by prioritizing traffic, combining multiple connections. We solve the same problem by making your data needing less bandwidth. So the two together multiply each other. And so that's why with Ericsson, we ran that test. And when they tested our product over their 5G router, network bounding, etc., they realized actually it worked perfectly. And not only that, but everyone worries about how much delay does it introduce, how much latency that adds, how much CPU does it need, how much memory on the edge router, and the guy said, look, to find the CPU consumption, he had to look in the decimal points to find our product CPU consumption. So that's a testament of how efficient our solution is. And then Ericsson and I, we did a webinar just about a month ago, and so it works really well. So that's just one of the reasons where in the telco space they're starting to pay attention. But I need to be specific. This product works on data, machine generated data. So IoT sensors, etc., not on video. The thing with video is when you do video compression, in video compression, there's multiple stage, and the last stage is what we call an entropy stage. So our product is not like video. It's not the lossy compression. And I need to be very specific. So in some cases in IoT world, they do some lossy compressions. They, some measurements, they drop decimals, these kind of things. We don't do that. We take a byte stream, and all the bytes that go in will come out in exactly the same way. Okay, so it's completely lossless, and it maintains the data as originally sent.
Wow. Well, definitely fit for purpose for IoT. And I can understand the performance implications, cost savings as well. What is the security opportunities, implications for using this on the network as well?
So, our product, we call it's a compaction tunnel. So it's fully secured. We had it pen tested. So we're using TLS 1.3. We're using the latest. That's all been verified. So absolutely no issues there. And you could argue it had an extra layer of obfuscation because we actually converting the data into this, what we call these code words, and you need to know the code books. So not only you have to break the encryption, but you have to find out what are these magic code words, and they're not like very obvious. And so, in fact, the professor in mathematics, the theory is that the byte stream that is generated even before encryption it already looks like almost random noise. It's already what we call maximum entropy. So there's no. So when you look at it, it would be very hard for you to distinguish where are the different code words, because it will look like this random bits, random zeros and ones coming in the flow. So that's pretty much why. But in general, we are fully secure.
Fantastic. Well, that's a nice validation as well. You're obviously well suited for almost any industry, but some more than others. I guess oil and gas, great example of an IoT use case. Any others that are really obvious and you're getting traction with?
Yes. So point of sale. So all your credit card devices, credit card machines, etc. And one of the big use cases is every time you make a transaction, the machine stores the receipt that has been printed electronically, so that it can then be transmitted to the bank. So if you have a dispute, customer says, it's not what I was charged, etc. Instead of requesting the merchant to send a paper receipt and have a photo or something, which is very time consuming and costs a lot of money, it's not worth doing if you're claiming for chips that you bought at McDonald's. Sorry, I should say French fries, and that you bought at McDonald's. Then the electronic receipt gets transmitted to the bank, and these things are quite large. There's 3 kilobytes, but when you have millions of transactions. So our partner in Saudi Arabia has been using it now for almost a year, our product, and is helping them to reduce on the daily basis, they generate 5 gigabytes, and we reduce that down to less than 1. And so that allows them to transmit the information, store it in disaster recovery sites much faster, and so on. Here's another example where, again, in Saudi Arabia, we've just been discussing with them. They are using it for replicating virtual machines. So all your application servers are running pretty much on the virtual machine, and you want to have a copy of that machine in another site for disaster recovery purposes. And they are using our product to make that copy up to 2 times faster, or even 2.5 times faster, which is quite unheard of, and it goes faster than any other tools they could use. So we got a series of examples where, yes, we can accelerate. It's not just about reducing your cost, but in some cases, when your bandwidth is limited, is being able to go faster. And the DR purposes, it's important. That means you can make your snapshots of the replication much faster. So if you had to recover from a disaster, you wouldn't have lost as much data as if you didn't use our product.
Fantastic example of your solution in action. Just let me ask you, big picture. We're being overwhelmed by AI agents now, and new endpoints and sensors and connected devices. I just think about me personally. I've got an Aura Ring, an Apple Watch, 3 eSIMs, Starlink, fixed wireless broadband, and as one person, right? I could probably name 20 devices with data being generated. How far away are we from networks being just overwhelmed by this kind of IP connectivity and data creation? Is this a problem that we're going to start seeing in actuality soon?
It's a problem that everyone is aware of. And I remember in the days when Apple started to send data back from their phones, and and people didn't realize, and suddenly I couldn't watch Netflix anymore, and that's just because all our iPhones were utilizing all the uplink bandwidth, and so when I was watching Netflix, my TV couldn't go back to Netflix and say send me the next packet because it was just congested. So what happens is a lot of people are aware of this. The telco operators are very well aware, and they're asking people to be more frugal with the utilization of the bandwidth, but it's still a big problem. On mobile devices like Aura Rings or even phones, they are very also aware of limiting that throughput because it's a radio device and they're battery operated. So the more radio communication happens, the more the battery gets drained. So they are the Apples and the Android, they are making sure that the applications are frugal on their communication. But this is where we actually can help as well, those applications, to reduce the amount of transmission time and therefore help preserve the battery longer as well. So it's not just the networks being congested, but you have to think about the longevity of the battery as well.
Great point.
And another example is recently I was discussing with Oracle OCI here at the headquarters in Europe with DXC, which is used to the old electronic data systems, General Motors, etc. And we're discussing automotive. And some people don't realize the electric vehicles, they have battery packs, and battery packs range from 400 cells to 4,000 cells in the Tesla. Each cell gets measured in terms of voltage, current, and temperature. So you multiply that by 4,000 measurements, multiply that by lots of measurements being taken because, hey, they need to make sure it doesn't catch fire. And all that information is stranded on the vehicle. And there is good research out there that shows if you can take that information and correlate it across a fleet of vehicles, you can further optimize the lifespan of your batteries, remove events. So the local battery management system, if it sees an overheating cell, it may shut it down, but it may be too late. Whereas if you can correlate that information much earlier, you can manage the cell before it gets too late and you have to permanently shut it down. So there's lots of stuff that where situations, electric vehicles is a very good example. And also in vehicles, all the assisted driving. So it's not just the fully automated driving, but all these extra sensors and things, lane departure warnings, all of that. All that information can be collected, correlated to ensure that they are working optimally. That creates a lot of data, and which is most of the time still stranded on the vehicle.
Yeah, fascinating. Every car is becoming a connected car now, not just EVs. So another challenge that you might be able to support, as you talk to industry insiders and customers, partners, what are some of the big misunderstandings or myths perhaps that folks have about AtomBeam and your approach that might need to be dispelled? I'm curious what some of the reaction is. Change is always a little hard. It's a new approach, new architecture. How's that discussion going?
I mean, so generally speaking, initially, the discussion is, it sounds exciting. That's the first reaction. Then the second reaction is sometimes when you talk with IT teams and things, engineers, they say, well, we can do the same thing ourselves. We can ourselves. The reality is, yes, you can, but not in the same way that we can do it. And so often the solution you will put in place will be a lot more complex than just stopping what we call the compaction tunnel, transparent inline. You don't have to change anything. You don't have to change your applications. You don't have, and that's whereas yes, you can do things yourself, but it's often it's sticky tape and wires. It's workaround. And the next time you have to do it again, and you do it differently. Our solution just will learn from the data. Some of the questions they go, well, what happens when the data changes? Well, when the data changes, we'll relearn, but how quickly do we relearn? And so those things, we've got new algorithms that will allow us to learn instantly as the data moves along, and with very little processing requirements. And so these are the things that no other systems can do. And then initially a lot of people, so we said, we transmit this codebook. Well, how big is the codebook? And so obviously the codebook, you can make it as small as you want. And in an IoT environment, like say this trial that we did for the oil and gas, we created one codebook, and we optimized it after 24 hours, and then after that it remained for 9 months.
Wow.
Okay, so people think the data changes a lot. Actually, it doesn't. But you have to, in an IoT environment, makes total sense. If you're in a telco router routing data for millions of customers all over the place, that wouldn't work there, because it's all quite random and so on. So, so that's why this edge is quite a good environment. A DR replication, that works quite well, because the workloads, the applications tends to be the same. Database replication, we also do 50% reduction. With it. So, all of this, if you were to combine it across an entire telco network, you would have to do it in a different way.
Interesting. Well, that was really insightful look into behind the curtain, as it were, into the technology at AtomBeam. What are you excited about over the next weeks, months, in terms of roadmap or deployments, or just generally, what is the team up to?
I mean, what I'm excited about is we're making some great improvement in terms of the maximum throughput that we can support. We're already at 250 megabits per second, and we know we're going to further exceed that. We got further enhancements that will allow us to be also very efficient over high latency satellite networks, and also further increase the throughput even for disaster recovery replication. So that DR site example I've given, we will be accelerating that even further. So, and these sort of algorithmics around monitoring the data and adapting to the data in near real time, that's also will be coming up. So the reality is there's plenty to be done with the product. And then once we've reached those improvements, then we will be looking at how do we shrink it and move it into microcontrollers, and potentially eventually getting into smaller devices. So we're partnership with Trilliant, who provide to smart grids and utilities, and they see our technology as being critical for what's called the AMI 2.0. So new metering, smart meters will collect a ton more data so that they'll be able to manage your smart grid, the electricity grid in a much more efficient way, especially because you now have solar panels, wind turbines, batteries, all sorts of things. That information is very verbose, and they partner with us because we're critical to enabling the collection of that information, taking it out of smart meters. So we will incorporate our solution inside the communication module that gets attached to the smart meters. And that's our first step to integrating in small modules. And then we will continue that sort of low level integration, which will eventually give us the ability to be, our long-term view is we should be in pretty much any device and optimize the network traffic everywhere.
Incredible. Well, that was quite a unique opportunity there. Thanks so much for sharing the vision and the mission and the opportunity. Really intriguing. Hope we can chat again in a few months and see how far you've progressed.
Yeah, thank you, Evan. And great questions. And real pleasure talking to you.
Likewise. And thanks everyone for listening, watching. Also check out our TV show, TechImpact.tv on Bloomberg Television and Fox Business. And till then, take care.